So hello everyone. Today we'll be solving the question edit distance. And this question says that we have been given two strings, word 1 and word 2, and we can perform either of these three actions and convert we need to convert word 1 into word 2. So this is a very standard dynamic programming question. So in this video we are going to be seeing the recursion plus memoization approach for it. Let's look at some of the examples. Like for example, we have one example where word 1 is horse and word 2 is rose. So how can we convert horse into rose? It's the approach is given here. First we can replace h with r, then remove r, and then remove a, and we will be able to convert word 1 into word 2. Now see, there are a lot of ways to convert word 1 into word 2. What we need to find is the minimum. What is the minimum number of ways we can perform these three actions and convert word 1 into word 2? So the word minimum is important here. So how did I think that dp will be used here? So for so intuition was, for each index we can either perform these three, and there's no greedy solution that, like, if we pick that then we can either skip that. There's no like intuition of greedy, whereas in dp we can try out all possible answers that will actually help in solving this question. This is where the intuition for dp came to my mind. So I'll explain it further. So let's start with an example, that is horse and rose. So I'll take it in a I've just taken it both at the same time for explaining. So I'm going to start with in first index of word 1 and first index of word 2, and I'll denote it as I comma j. So what do we have here is that we have three choices. Either we can, for our I and j we have three choices. Either we can insert a character, we can delete a character, or we can replace the character. Now we need to know in which index we need to perform the action and what is going to be the output of that action. For example, if we insert something, so what is the thing that needs to be inserted? See, we need to convert the left word into right word, right? So the index in which the element is present, we need to perform element on that only. So for example, here we have been given word 1 and word 2. For I and j, we will first try to, I and j are gonna move such that we will be able to find all possible variations of all three problems that we have been given. Like it's gonna either insert r, and then inside insert r there are again three choices of we can replace, insert, or delete. So we will have to either choose one, then again. It's like a graph, recursion graph. So using this only we are gonna proceed with this. So what happens if we insert r? We insert r means, okay, we have inserted the j position and we found the answer. So we just need to pick up j and put it in the next index, because we have already seen the it's similar to this. Like if both indexes are equal, then I plus 1 j plus 1. That's what we are actually doing here. That here it will be r will be inserted here, so we just put the index I plus 1. Similarly here we did j plus 1. So overall what it's gonna look like is I comma j plus 1, which means our index does not change for I, and for j our index goes one further. Now let's see what happens at delete. What delete does is it deletes the ith index, hoping that in future we might find the j index. That's the logic of delete. So what it actually does, I plus 1 comma j. Now what does replace does? Replace means replace the ith index with the j index. So yeah, what replace is trying to say is that okay, we are gonna replace the jth term with the I, which means both terms are equal, so we are just gonna jump to the next index. And of course this will result into ROR and SE. Then again we will find three possible answers for all three. Similarly we have three choices for each term, and for again each term we will have three choices. Now the interesting part here is what is going to be the ending condition, that once j go out of bound, then we that it actually means that we have uh, equated our word 2 with word 1, and there's nothing to equate now, so we just need to delete all the characters from afterwards. For example here ROS and here ROSE. What when I is at R, what we can do is just delete. Either we can delete or either we can just replace it with S, and ROS we will finally get our answers. So though we do not need SE here, so we'll have to delete them. So our ending condition is going to be, if j is equals to n, we're just gonna return what is left, that is m minus I. Delete all the terms after j, and if suppose if I reaches the end, then we're just gonna do n minus j. So this was the approach, and this is a pseudocode that we need to call a solve function. And the in solve function there will be two integers s1 s2 I and j. If I is equals to s1 dot length, that is what we discussed here, that if I goes out of bound, then we just gonna return I n minus j, that is insert all the characters that we need. And if j is equals to st dot length, we're just gonna return m minus 1, all the deletions. So here I want to say one thing, this term, if I is equals to m, which means that I is going out of bound, j is not out of bound, which means there are actually more characters we need in I. And what are those characters? They can only be gained by using the term insert. That is the reason why we have written n minus j here. Okay, so yeah, this is a pseudocode, and this is the important condition, that if we found that two elements are equal, then we are just gonna jump I plus 1 j plus 1 to compare the next terms. And these are the main conditions, that if that is insert is equal to 1 plus I plus j plus 1, how we solved earlier. When we do delete, it's I plus 1 comma j, and we will, when we replace, it's I plus 1 and comma j plus 1. And we just need to, as we need to find minimum answer, we just need to return minimum of these three. Yeah, so let's code it up. Yeah, so first we need m and end. So m is equals to word1 dot size, and end is equals to word2 dot size. And yeah, I have to also initialize it, and m and n. Okay, and I just need to pass a function solve. I'll name it s1 comma s2 comma 0 comma 0. Okay, 0 comma 0 means we, for both word, we are starting from the 0th index. So let's write up the our solve function, and solve, sorry, and solve string. I'm just gonna copy it here and paste it. I'll name it s1. Similarly, I'm name it s2, and sorry, and I comma int j. Okay, let's make the function now. So what was the starting of the function? That we need to make the base condition where the recursion needs to start. So what was it? Either if j go out of bound or I go out of bound. So if suppose I is equals to m, then we are just gonna return okay, return m minus I. Yeah, and this actually means that deletions, that we need to delete all the elements after m. Now if j is equals to n, that is j reaches the end element, then we are just gonna return n minus j. It means that I does not have enough terms, so we need to insert them. Okay, so these are the base conditions. Now what I need to write is an important condition, that if our s1 of I is equals to s2 of j, then we are just gonna return the solve function s1 comma s2 comma I plus 1, that is we are going to be jumping to the next term. Okay, that makes sense. Okay, this much is done. Now let's initialize our integers, that is int insert, int delete, and int replace. So it means 1 plus solve. What we used to do insert, we used to insert in the I remains at the same position and j goes plus 1. So it will be I comma j plus 1. Similarly for delete, wait, you need to need to use delete. That when we delete we delete the ith term, hoping we could find an character equals to jth index in future. So j remains the same, I goes I plus 1, so it will be 1 plus solve s1 comma s2 comma I plus 1 comma j. Now let's talk about replace. So replace means replace the ith term with the j, which means both are equal, so both need to go one index afterwards. So I'm just gonna 1 plus solve s1 comma s2 comma I plus 1 comma j plus 1. Yeah, this is it. And I think that we just need to return minimum of, okay, I know that this whole, first of all I'll write it, comma delete comma replace. So I know that this whole should be inside else block, but let's try to run it without it being in the else block. Let's see what happens. We are getting an error. Delete. Why am I getting an error here? Okay, delete should be not. Delete C. Delete C. I think this is better. Unidentified S1. Okay, here should be word 1 and word 2, right? Word 1 and word 2. Okay. Okay, I need to return this, right? Yeah, it works. Like, yeah, that the problem that I knew was that there should be an else block here, and I think this was the reason it's failing. Yeah, that doesn't even solve the question. What is the reason that I'm failing? Okay, here if it will be n minus j, not n minus I. Let's run it now. Yeah, now it works. Okay, so I'll also try to remove that else block. I'm trying to see if it will work or not. Oh no. Why am I getting this error? Okay, let's try to run it. It works. Let's try to submit it. Okay, we are getting a memory limit exceeded. So does that mean that we did not need that as block? Let's try memoizing it and then we will know. Int dp, what is the constraint here? 501 501, and here the condition for dp, if dp of I comma j is not is equals to -1, then we are just gonna return dp of I comma j. Okay. Also I'll copy it so that I can future return. Yeah. And in here we can just do memset of dp comma -1 comma size of dp. Yeah. Now let's try to run it. What is this? It should be z. Let's now try to submit it. Okay, it got accepted. There was no need for else here. It works completely fine. Okay, so this was it for the video. Thank you.